Okay, welcome back, guys. Makebalo. Thank you so much for keep on supporting the channel. The channel is drawing me steady but surely. But thank you for liking the channel, subscribing to the channel. If you haven't subscribed, make sure please you press that button, and also comment if you want something. Just say something nice. If you want to say anything about the topic that we did, or you want to recommend something that I should make a video on, don't hesitate, please type. And then today we will be continuing with our probability counting principle under grade 12 curriculum. So today we'll be looking to this question here, which is 12.2, which is saying the letters in the word curriculum. Let's just write this word down. As I'm writing it down, as you see that there are letters that are repeated in this word. There are letters that are repeated in this word. So curriculum are rearranged to form a word or to form other words. Assume all the words have a meaning. Now going to the question that we asked for, they're saying how many different letter arrangement are possible. So we need the arrangement of this word that are possible. Mind you, there are letters that are repeated here. We have U that is being repeated, and also we have ubani, C that is being repeated, and also we have we have R that is being repeated, and also we have I that is I is not repeated. I is not repeated. Our U is repeated 3 times here. So we have C that is being repeated. We have U 1, 2, 3 that is repeated, and also we have R that is repeated. Oh, this one is not repeated. Sorry about this one. Sorry about this one. So now finding our arrangement here, how many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 letters. So it's 10 factorial all over. Since we have letters that are repeated, so we must divide with the letters, number of letters that are repeated. First we have C that is being repeated. How many times? 1, 2. So C is repeated 2 times, so it's going to have 2 factorial times. Also have U is repeated how many times? 1, 2, 3. So U is repeated 3 times, so we have 3 factorial. Then we also have R that is repeated how many times? 2 times, so we have times 2 factorial. So finding the arrangement there, 10 factorial and 2 factorial times 3 factorial times 2 factorial, and then our answer here we get 151,200. So this is our answer we are getting from the arrangement of this word. Don't forget, if we have in the word, if there are letters that are being repeated here, you divide by the numbers of those words. Don't forget to put the factorial, and also we times the letters that are being repeated there when we divide here. Now let's go to this one, 12.2.2. Now they are saying what is the probability. One of the important word here, they are calculating the probability now that a word will start and end with what? With the letter U. Letter U. Now we said we have 10 words. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have letter U. Now they are telling us that we're going to use U here at the first, so 1, and at the last also here we're gonna have what? We're gonna have U. So we know here we have U, and then here we have U. And then how many letters that are left there? You have 10. We've already used 1, we're left with 9, we've used another 1, we're left with 8. So 8 letters that are left. So it's gonna be 8, 7, 6, 5, 4, 3, 2, 1. And then we times. Now we know from here to here it's what? It's 8 factorial. And then times this one here, and then also times this one here. Not forgetting this weight has the letters that are being repeated there. There are letters that are being repeated there. Don't ever forget that one. Remember, we use U at the first, we use U at the last. These two are fixed. They are not going to change. The U that is here, it's fixed. The U that is here, it's fixed. Only the letters that are left here that are being repeated is what? It's C that is not fixed. So we have 2 factorial. C are they repeated 2 times. And also we have what? We have R, which is 2 factorial. Remember, U was 3. We've already used the 2 U's at the first and the last. We've already used those ones. We already left with the 1. So this one now is no longer repeated. It's just 1 U. I hope you don't forget that one. Then we get our answer from here. That's what? It's 1 times 8 factorial times 1 over 2 factorial times 2 factorial. We get our answer here, which is 10080. Don't forget, we haven't answered the question. The question, they said they want what? The probability. So we want the probability of start and with the letter U. We want the probability. Remember, how do you find the probability? The probability is the arrangement of the restriction that they gave us here. This is the restriction that they gave us, which is 10080, all over the total arrangement, which is the total arrangement that the one that we found here at the first question. So it's 151,200, and find our probability, which is 1080 all over 5122. Then it's 1 all over 15. So this is our probability of starting with and end with what? With U. Okay guys, now continue with question 11, which is 11.1, which is saying we have the digits from 0 to 9 to use to form what? To form code. So now 11.1.1, it's saying determine the number of different 6-digit code that can be formed if repetition is allowed. If repetition is allowed, we are forming what? 6-digit code. So 1, 2, 3, 4, 5, 6. Now, important thing, repetition is allowed. And from 0 to 9, these digits are how many? They are 10 digits, counting from 0 to 9. And repetition is what? It's allowed. So we're gonna say 10, 10, 10, 10, 10, 10, times in all these 10s, because the repetition is allowed. So we have 6 10s, so it's 10 raised by 6, which is 10, which is 100,000. Then now going to the second question, which is 11.1.2. now they are saying determine the number of 6-digit code that can be formed that start with 9 and end with 2 if the repetition of the digit is not allowed. Now 1, 2, 3, 4, 5, 6, forming what? 6 digits. Yes, we are forming 6 digits. They are telling us that they want number 9 here. We want number 9 here, so we're gonna start with 9 here. And then they also want what? Number 2 here. That's what they are telling us. So these numbers that are here are fixed. So we have 9 here, 1 9 here, and then we have 1 of 2 here. These two are fixed. They are here and not gonna move. Now forming 6 digits from how many numbers that were left? They already used 2, they've already used 9. Out of 10, we are left with what? With 8 digits. So it's 8, 7, 6, 5. Then we times our answer. So it's 1 times 8 times 7 times 6 times 5 times 1. We get 1680. So it is the arrangement of the code that we can form from this question. I hope everyone is understanding. 11.2. now it's saying the digits from 0 to 9 are used to form 10-digit code. Okay, now determine the number of 10 code that can be formed if, now which is our restriction here, if 2 and 3 may not appear next to each other. If 2 and 3 may not appear to each other. So now how to tackle this question? Tackling this question, we're gonna start by doing the opposite of what they are asking here. They are telling us that 2 and 3 may not appear next to each other. We're gonna start by saying or by calculating that 2 and 3 they are going to appear next to each other. We're gonna start by doing the opposite of what the question is what it's saying. So let's start by doing that. Let's start by saying may appear next to each other. Let's start by doing that. So now we have 10-digit codes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now 2 and 3, we are doing that. They're gonna appear next to each other. So they're gonna be in the box here. 2 and 3, they're just gonna be next to each other in whatever arrangement there's going to be made here, or whatever code that is going to be made here. So 2 and 3, they're gonna move up and down inside this box. So let's make the arrangement inside here. So it's gonna be 2 times 1, which is just 2 factorial, which is give us what? It gives us 2. And then now let's do also the arrangement when now it's happening here, and also including the box of this. So if you can count including the box, you count 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you can count them here, how many do we found? We found 9. So we're gonna have 9 factorial. Finding 9 factorial. What is 9 factorial? 9 factorial is 362,880. So this is a 9 factorial. So if you can times the 2, which is 2 factorial, times 9 factorial. What do we get? And times 9 factorial, we get 72570. So now remember, this arrangement here is the arrangement that, or is the code that 2 and 3 may appear next to each other. So now how do we get the question? Now how do we answer the question that we are asked? Now let's say now may not, now we are answering the question, may not appear next to each other. Now let's go to what we are supposed to answer. First thing that we need to do here, we must find the arrangement of these letters here from 0 to 9. How many numbers we have here, or how many digits of this code? There are 10. So you must find the arrangement here of this 10 factorial. That's the first thing we need to find, which give us 36280. First thing we need to find, we have 10 digits. We must first find the arrangement of the code of the numbers that we have here. After that, now how do we find this? May not appear. How do we find them? Find them by saying this is the arrangement that we have of the code, all of the digits. Now we already found where then 2 and 3 may appear next to each other. How do we find if they are not gonna appear next to each other? We're gonna minus this one that we found here. That's saying it's gonna appear next to each other. This is, we found the arrangement of all the numbers. We found the arrangement of saying that 2 and 3, they're gonna appear next to each other. Now how do we find that the two numbers here may not appear to each other? You take the arrangement of all the numbers, we minus the arrangement of these two numbers that's saying they appear next to each other, in order for us to find if they are not gonna appear next to each other. That's how we do it. So it's 10 factorial minus into 2 factorial times 9 factorial. Then we find what? 2903040. So this is how we find may not appear next